We begin our alignment work with Softfoot measurement, so we will select program 13. The laser beam comes on and we adjust them into the center of the targets using the side adjusting thumb wheels. This is done at the 12 o'clock position. All we are doing is putting the beam into the center of the target so that we have a full range of measurement. We are then prompted to take the tape measurements, and we need the distance between the S and M units, from white line to white line. Next, the distance from the S unit to the center of the coupling, then the distance from the S unit to the front foot, foot 1, and finally, the distance from the S unit to the back foot, foot 2. Now we can input the information. The distance from S to M is 6 inches. The distance from S to C is defaulted to half the previous measurement but is actually 2.5, so we overwrite the 3. The distance from S to foot 1 is 10 inches, and the distance from S to foot 2 is 16 inches. The display prompts us to put in the measuring units at 12 o'clock, which we do. We will also disconnect or open the coupling, because the best way to measure Softfoot is to have nothing attached to the machine that you are measuring, no piping or coupling. Now we press the enter button, and the display highlights the front right side foot. We loosen the foot, then retighten and press the enter button, and any soft foot is recorded. Now the right rear foot is highlighted, and again we loosen and tighten the foot and press enter to record the value. We move to the next highlighted foot and continue taking measurements. Take your time when doing this work. The goal is accuracy, not how fast you can do it. Remember, Softfoot is, in most instances, the result of a twisted base or distorted machine's foot, and it is your job to find it. If you need help with this, email us and ask us for our Softfoot correction procedure, and we will send it to you free of charge. As you can see from the final results, we have very little Softfoot under 2 thou, so that we can proceed with the alignment. We do this by pressing enter and selecting an alignment program. We can select program 11 and do an open coupling alignment. All the tape measurements are already in, so we can start to measure the misalignment. We move the S unit to the 9 o'clock position using the spirit level. Next, we move the M unit to the 9 o'clock position, leveling it with the spirit level. We then press enter to record the measurement. The display now prompts us to move the units to the 12 o'clock position, so we will move the S unit first. We use the spirit levels on each unit to position the unit at the top of the vertical plane. Now with the units in a stable position, we press enter to record the measurement. The display prompts us to move to the 3 o'clock position, which we do, and the spirit levels allow us to position the unit level at 3 o'clock, where we record the last measurement. We can now see the measurement results. The top part of the screen is the vertical plane, and we can only see 2 feet, which means we have to lift or lower the machine in this plane. The lower part of the screen is the horizontal plane, and we are looking straight down on it so we can see all 4 feet. This means we slide the machine left or right to align. Starting at the top of the screen, the first number shows the amount of offset in the vertical plane measured at the coupling, which is negative 26 thou. The next number is 1 thou per inch of angular error, again, measured at the coupling. To correct the vertical measured misalignment, you need to adjust the feet as indicated by the 2 numbers below. In this case, you would add 35 mils or thou of shims to both of the front feet and 42 thou of shims to both the back feet. Remember, when you see a negative number, you add. Now looking in the lower horizontal part of the screen, the first number is 31 thou. This is the amount of offset. The angular misalignment is 2.5 thou per inch. Both results are measured at the coupling in the horizontal plane. To correct this, we have to move the 12 thou at the front foot and the negative 3 at the back. These results will change as we make the corrections in the vertical plane. We now make the corrections in the vertical plane. After loosening the bolts, we can add the amount of shim shown on the screen to both the front and back feet of the machine. After adding the correct amount of shim, we can now work in the horizontal plane. To correct the horizontal misalignment, you need to move the machine by the amount shown. Notice that the feet are black. This indicates that it is reading live in the horizontal plane. You can see the values change in lifetime movement on the display as we correct the horizontal plane misalignment using the jacking bolt. If we wanted to have it read live in the vertical plane, you simply turn the heads to the 12 o'clock position and press the button 5. We have made all the corrections. The trick is to keep from moving the machine as we retighten the bolts. Once it is tight, we have the option of pressing the button 9 or the back arrow to remeasure. We press the back arrow. The screen prompts us to move the measuring units to the 9 o'clock position and record the measurement. Then on to 12 and 3 and do the same. Again, we should not rush this. We want a good stable reading. Remember, it's easier to hit a fixed target than a moving one. The results speak for themselves. It is perfect in the vertical plane and 1 thou out in the horizontal. If we wanted to correct this, we would trim the machine 2 thou to the left. However, the tolerance for a 1725 RPM machine is that 4 thou is acceptable and 2 thou is excellent for offset. With 0.8 thou per inch as acceptable and 0.5 thou per inch as excellent, we are well within the excellent range, and we did it in one move. It was easy.